So now let's talk a little bit more about energy transfer by heat. Energy can cross the boundary of a closed system in two distinct forms, heat and work, as you can see in figure 2.14. It is important to distinguish between these two forms of energy. Therefore, they will be discussed first to form a sound basis for the development of the laws of thermodynamics. We know from experience that a can of cold soda left on a table eventually warms up and that a hot-baked potato on the same table cools down. When a body is left in a medium that is at a different temperature, energy transfer takes place between the body and the surrounding medium until thermal equilibrium is established. That is, the body and the medium reach the same temperature. The direction of energy transfer is always from the higher temperature body to the lower temperature one. Once the temperature equality is established, energy transfer stops. In the process described above, energy is said to be transferred in the form of heat. Heat is defined as the form of energy that is transferred between two systems or a system and its surroundings by virtue of a temperature difference. That you can see in figure 2.14. That is, an energy interaction is heat only if it takes place because of a temperature difference. Then it follows that there cannot be any heat transfer between two systems that are at the same temperature. Heat is energy in transition. It is recognized only as it crosses the boundary of a system. Consider a hot baked potato. The potato contains energy, but this energy is heat transfer only as it passes through the skin of the potato or the system boundary to reach the air, as can be seen in figure 2.16. Once in the surroundings, the transferred heat becomes a part of internal energy of the surroundings. Thus, in thermodynamics, the term heat simply means heat transfer. A process during which there is no heat transfer is called an adiabatic process, as given in figure 2.17. There are two ways a process can be adiabatic. Either the system is well insulated so that only a negligible amount of heat can pass through the boundary, or both the system and the surroundings are at the same temperature and therefore there is no driving force or a temperature difference for heat transfer to occur. An adiabatic process should not be confused with an isothermal process. Even though there is no heat transfer during an adiabatic process, the energy content and thus the temperature of a system can still be changed by other means such as work. As a form of energy, heat has energy units SI kilojoules or BTU in English units being the most common. The amount of heat transferred during the process between two states 1 and 2, is denoted here as Q sub 1, 2 or just Q. Heat transfer per unit mass of a system is denoted by simple Q and is determined from capital Q divided by M mass, and the answer is given in kilojoules per kilogram. Sometimes it is desirable to know the rule of heat transfer or the amount of heat transferred per unit time instead of the total heat transferred over some time interval like given in figure 2.18. The heat transfer rate Q dot or capital Q dot has the units of kilojoules per second, which is equivalent to kilowatts. Then capital Q dot varies with time. The amount of heat transfer during a process is determined by integrating Q dot over time interval of the process. That you can see in equation 2.15. Here, the amount of heat transfer Q could be arrived by integrating Q dot dt between initial and boundary conditions of T1 and T2. And when capital Q dot remains a constant during a process, the above relation reduces to capital Q amount of heat transfer would be equal to capital Q dot times delta T, where delta T equals T2 minus T1 is the time interval during which the process takes place. Heat is transferred by three mechanisms: conduction, convection, and radiation. Conduction is the transfer of energy from the more energetic particles of a substance to the adjacent less energetic ones as a result of interaction between particles. Convection is the transfer of energy between a solid surface and the adjacent fluid that is in motion, and it involves the combined effects of conduction and fluid motion. Radiation is the transfer of energy due to emissions of electromagnetic waves or photons.